How do we measure temperature? Temperature is an essential measurement for effectively monitoring and controlling various industrial applications. Not ensuring accuracy, the incorrect temperature measurement and control can lead to insignificant and faulty temperature recordings. Incorrect measurements can cause equipment failure, inferior quality of a product, and even severe risks to human health. For example, controlling the right temperature in the food and beverage industry will ensure the food's quality, flavor, and freshness. If the temperature monitored is not correct, the wrong temperature can lead to health risks for consumers. Devices are used to measure the temperature accurately, depending on specific applications. An example of two devices used in industry is thermocouples, or TC, and resistance temperature detector, or RTD. We will start by defining the resistance temperature detector, or RTD sensors. The RTD can be constructed as a small coil made of a wire-wound element as a precise value resistor, mainly around a glass or ceramic bobbin. This construction will allow it to expand and contract over temperature ranges freely. The winding is generally done in helix or birdcage construction. The RTD is also a passive device. It must be powered by an external electronic device to measure the resistance as the RTD temperature changes. The electronic device generates a small electrical current through the RTD resistor sensor to generate a voltage output as the result of the measurement. Next, let's define the thermocouple, or TC sensors. The thermocouple is two different types of metals welded together at one end, creating a junction. Therefore, when the junction of the two metals is heated or cooled, a small voltage is produced from the heating or cooling effects and can be correlated directly back to the temperature. The thermocouple is an active device. What materials are used to make an RTD or thermocouple sensor? For the RTD sensor, the most common elements used are nickel, platinum, or copper wire. Nickel has a high resistance to corrosion, making it ideal for use in harsh environments. It also has a relatively low cost compared to other materials, making it a popular choice. However, nickel has a relatively high temperature coefficient, which means that its resistance changes only rapidly with temperature. Platinum, on the other hand, has a high temperature coefficient, making it highly accurate for temperature measurement. It is also corrosion resistant, making it ideal for use in harsh environments. However, platinum is much more expensive than nickel, which can make it less desirable for some applications. Finally, copper has a high electrical conductivity, making it ideal for use in applications where a fast response time is required. It is also relatively low in cost compared to platinum. However, copper is not as corrosion resistant as nickel or platinum, making it less suitable for use in harsh environments. As for the thermocouple sensor, different conductive metals will produce different levels of small voltage or charge. The most common types of thermocouples are denoted by a lettering system, such as K, J, T, and E. Each letter refers to a specific combination of two different metals used in the thermocouple. These metal combinations are selected for their unique characteristics, such as accuracy, response time, and temperature range. For example, a K-type thermocouple is made of chromel and alumel metals and is often used in high-temperature applications, like furnaces and boilers. On the other hand, a J-type thermocouple is made of iron and constantan metals and is used in low-temperature applications, like refrigeration systems. The choice of the right thermocouple type depends on the specific application, so it's essential to choose the right one to get accurate temperature readings. The RTD and thermocouple sensors have a measuring range depending on the material type used and the application. An RTD can be used in temperatures ranging from -200 degrees Celsius to +850 degrees Celsius. In comparison, the thermocouple can measure from -250 degrees Celsius to +1800 degrees Celsius. When we compare some of the most common features of RTD and thermocouple temperature sensors, we find, as shown by the chart, some of the pros and cons. For example, the measuring range for an RTD is between minus 200 degrees Celsius and plus 850 degrees Celsius. But for a thermocouple, this is minus 250 degrees Celsius to plus 1800 degrees Celsius. So, if you need to measure a temperature that can go as high as 1000 degrees Celsius, then thermocouple is the sensor you can choose. Or if you need more sensitivity, RTD is a better option. Response time refers to the amount of time it takes for a temperature measuring device to indicate a change in temperature after the temperature is actually changed. In the case of RTDs, or resistance temperature detectors, and thermocouples, response time can vary based on several factors, including the size and material of the device, the surrounding environment, and type of thermometer used. Generally, RTDs have a slower response time than thermocouples, but are more accurate over a wider temperature range. In high-temperature applications, thermocouples tend to have a faster response time, but their accuracy can be affected by electromagnetic interference. In order to choose the appropriate temperature measuring device, it is important to consider the specific requirements of the application, including the required accuracy, temperature range, and response time. These are just a few of the most common features. Always refer to the data sheets for each temperature sensor before selecting it. So what are some of the pros and cons of RTD and thermocouples to be considered before making your selection? Here are just a few points to consider before you select the RTD or a thermocouple. RTD can measure lower ranges. RTD is more accurate, and RTD output is linear. RTD is more expensive. RTD is unsuitable for temperatures over plus 850 degrees Celsius, or in other words, 1,562 degrees Fahrenheit. And RTD has a slower reaction time as related to temperature changes. And these are some thermocouple points to consider. Thermocouple is cheaper than RTD. Thermocouples can measure a higher range, and thermocouple reaction time is faster. The output of the thermocouple is nonlinear. Thermocouple has poor accuracy, and thermocouples have poor stability with output results. In applications where you require the highest accuracy, where cost is not a concern, and your measuring temperature is less than plus 800 degrees Celsius, then the choice of an RTD is the best one. And as for thermocouples, where temperatures exceed plus 800 degrees Celsius, then your best sensor would be the thermocouple. Many factors should be looked at first before choosing the correct sensor for your application. Here are some factors to consider when choosing a sensor for your control application. The measuring range of your application. Measurement accuracy you will need from your application. The measurement drifts over time of use. Single-point measurement narrowed down to the exact spot. Sensitivity of the sensor. And cost of the sensor. These are just a few factors for consideration before making your decision. I mentioned at the beginning of this lesson that RTD and thermocouples could be found in all types of industrial applications, like the food and beverage industry, controlling the process of temperatures in ovens, heaters, and freezers. They can also be found as close as in your automobile, monitoring the exhaust gas temperature of your tailpipe, engine temperature sensor, and even your engine oil temperature. These are just a few considerations the design engineer must consider before deciding. In conclusion, in this video, you learn the difference between RTDs, or resistance temperature detectors, and thermocouples for temperature sensing applications. Here are the key takeaways from this video for you. RTDs are more accurate than thermocouples in temperature measurement. RTDs have a temperature accuracy of plus or minus 0.5 degrees Celsius, while thermocouples have an accuracy of plus or minus 2 degrees Celsius. Thermocouples have a wider temperature range compared to RTDs and can measure temperatures from minus 250 degrees Celsius to plus 1800 degrees Celsius, while RTDs can measure temperatures from minus 200 degrees Celsius to plus 850 degrees Celsius. Thermocouples have a faster response time compared to RTDs, with RTDs having a slower response time of 1 to 2 seconds. Thermocouples are less expensive than RTDs, making them the preferred option for applications that do not require high accuracy or where cost is a major concern. RTDs are more stable and long-lasting compared to thermocouples, as RTDs are made of high-quality materials and are less susceptible to damage. As you can see, both RTDs and thermocouples have their advantages and disadvantages, and the choice between the two depends on the specific requirements of the temperature sensing application. Ready to take the plunge into RTD knowledge? The Complete Introduction to RTDs course on RealPARS is your perfect guide. Designed for all skill levels, it's an easy-to-follow class that will teach you everything you need in no time. Check out the link in the video description and get started today. Have questions about RTD or thermocouples? Drop them in the comments, and we'll get back to you with helpful answers faster than 24 hours.